Commercial Energy Efficiency 101. I've worked with Greg for a few years. Great guy, knows what he's talking about. Greg is the Vice President of the Utah-based energy efficiency firm, ETC Group, and is Director of their new construction group. He is a leader of the Utah Sustainability Community, helping to establish the Utah chapter of the U.S. Green Building Council. Greg is a licensed professional engineer and is a lead accredited professional. He holds a master's in mechanical engineering from the University of Wisconsin, Madison Solar Energy Lab. Greg's professional interests in the energy efficiency field include high-performance buildings, energy simulation, commissioning, and energy auditing of existing buildings. He has provided energy consulting for numerous new construction projects, including office buildings, high-rise residential, retail, higher education, manufacturing, healthcare, and recreational centers. Greg has performed energy assessments of over 100 existing facilities, helping owners identify and implement energy efficiency improvements in their facilities. So, Greg, you've got about 45 minutes, so there we give him a round of applause.
All right, I'll take me a little bit here to get my handle on the computer and there we go. Can everybody hear me if I don't talk into the microphone, or should I talk into the microphone?
Talking to the mic.
Talking to the mic, okay. I'll do my best. So this is Commercial Energy Efficiency 101. My name's Greg Schlegel, and as Jake said, I'm Vice President of ETC Group, a Utah-based energy efficiency firm. Oh, there we go, just a little slow. A little bit about ETC Group. ETC Group is dedicated to improving energy efficiency of our clients' commercial and industrial facilities. That's what we're about. We're not about design. We're not about anything else. We focus on energy efficiency. This quotation, I think it's from our mission statement, kind of is a little more elegant than what I'm spitting out right now, but I think it summarizes it well. We've been in business for over 23 years in Utah. These are some of our service offerings: energy assessments. We'll talk a lot about that today. Energy management, that's another focus of the conversation today. Commissioning, recommissioning, system optimization, implementation assistance, and new construction design assistance. And we also dabble in a little bit of education outreach and policies through some work with the Department of Energy. So that's a little bit about ETC Group. Today what I'm going to talk about, remember this is Energy 101, and the first thing we're going to talk about is energy management. Basically managing your utility consumption. After you figure out how much energy you're using, see if I can adjust this a little bit. How's that work? That'll keep me from bending over. We'll talk about energy management, getting your handle around how much energy you're using. Once you've got a handle on how much energy you're using, we're going to kind of talk about, well, what do you do with that? And how do you assess the efficiency of your facility? How do you go about improving your facility through energy auditing or perhaps a recommissioning or retrocommissioning process? Energy management is all about measurement. I mean, that's exactly what we're doing. And you really don't know how you're performing unless you're doing some sort of measurement. It's a little bit eye-opening once you get into the industry and you find out how little measurement is going on out there. I think it's going to change. One of the things we're working with the state of Utah, and we're looking at building performance for a number of their buildings. And we've spent probably the last month trying to get utility data on DFCM managed buildings. And it's hard. It's really hard to get your hand on utility data for buildings. Same thing for Salt Lake County. We work for Salt Lake County. This is not I'm not picking on DFCM. I'm not picking on Salt Lake County. It's just, we need to start doing a better job of managing our utility use. Because we don't know. I mean, if we're not paying attention, we don't know how we're performing. We don't know how much we're spending. What if you've commissioned an architecture firm or somebody to design a green building for you? Do you know what you're getting? You're supposed to have 30% energy savings over code. If you don't measure it, are you getting value out of that? And the other thing that you can find out from looking at your utility bills is everything in your building working right? Maybe you've got some heat tape on your roof that's pulling 10 kW or something like that. That's going to show up on your utility bill, but it's going to be darn hard to see anywhere else. So you got to take a look at it. Got to keep taking a look at your utility bills. The reason I think this is going to change a couple things. The USGBC, I think, is going to drive some change in this matter. They got beat up about 2 years ago when the New Buildings Institute did a study on LEED building performance and found that there wasn't really a great correlation between your LEED certification level and your energy performance. There were LEED Platinum buildings that were great energy performers, and there were LEED Platinum buildings that were terrible energy performers. In the next version of LEED in 2012 that's coming out, it looks like they're going to require, one of the challenges in this NBI study was they couldn't get utility data either. So it's just to kind of reinforce, it's a common problem. But what they're going to require in 2012, at least it looks like they're going to require, is they're going to require metering, whole building energy metering and reporting. So they're going to make people that want to play in the LEED rating system, they're going to make them measure their energy consumption and then report it. So that's going to require facility owners to implement an energy management system, which is great. So whenever you measure something, you need a benchmark, right? What's your yardstick? The standard yardstick in the industry is the CBEX data set. So if you ever hear anybody say CBEX, what that is the Commercial Building Energy Consumption Survey. The easiest way that I find get access to this information is I just go in and Google CBEX 2003. Let's see if I can get this to work. It's always dangerous, I think, when you try to use the internet in a presentation. And yeah. Anyway, so if you just go Google CBEX 2003, what'll pop up are about 100 tables. And well, here we go. It's a little slow, but it's coming. There we go. So here are your tables. And it's just a great wealth of information of the United States building stock. And you can go in here, and as you can see, it's an extensive data set. I like to go down to the C tables. This is where the information that's meaningful to me is. C10 is one of my favorites. It's kind of terrible that I actually have a favorite table in the CBEX data set, but it gives energy intensity by climate zones, total energy. It's the EUI, basically, total energy consumption per square foot, sliced up by climate zones for all kinds of different building types. And it's a great way to get an idea of how your building should be performing or how your peer group is performing. I encourage you all in your spare time, or if you're interested in energy management or energy performance of buildings, Google CBEX 2003 and take a look at the data. As you can see, there's A, B, C, and you can get down and it gives you lots of great information. The disappointing thing about the CBEX survey is that this is a survey that's done every 4 years. 2007, the data was flawed, so they could not publish the data. I don't really know why it was flawed, but that's the message that was put out there. And recently, the funding's been cut. So this 8-year-old data is the best that we have in the United States for our building stock performance. The next bullet down, energy intensities. This is some of the stuff that you can get out of the CBEX data in all those different tables. Energy intensities, they slice it up by climate zone, size, number of floors, building types, year constructed, and on and on and on and on. It's really good information. One of the best things is they give you an idea of where your energy is being consumed, an end-use breakdown in your building or the different building types. So really valuable information in the CBEX data set. So energy management is about managing your utilities, measuring your energy consumption, and comparing it to a benchmark or a yardstick. I encourage everybody to do this at home. How many manage your utility bills at home? Great, a spattering. It's kind of what I do. I've got my own little spreadsheets and some charts and what have you. And I'll kind of air my dirty laundry here in a little bit. But a goal for everybody, just kind of a standard goal. It always depends on what you've got in your house and how big of a house you have. but you should have about a 1 kW load in your house, and there's 730-ish hours in a month. So you should be consuming about 700 kilowatt hours per month. That would be a goal on a residential side. If you're doing that, you're doing a pretty good job. At work, if you don't manage buildings, you should encourage whoever has your utility bills to track your utility consumption. If you're a tenant in a large office building, you should be able to track that, monitor that, and then you can look and see, well, hey, wait a second, we've got a lot of load at night, but there's nobody here. What's going on? Let's turn our, let's turn our computers off at night, or put on some energy saving features on our computers. If you happen to be managing or responsible for a lot of buildings, it's critical that you manage your utility bills, and then you can start figuring out where your low performers are, and you can start targeting those for energy audits or the retro-commissioning process. And we'll go into that more in a little bit. I think I said this before, but invest in energy efficiency. I mean, if you try to invest in the stock market right now, it's a wild ride. We see energy efficiency projects regularly that have a 25, 50%, 100% return on your money. Simple paybacks of a year, simple paybacks of 2 years, 4 years. It's a great investment, and right now people, for whatever reason, don't hold on to that opportunity. Banks don't believe it for some reason, but we're getting there. Energy management, as I said before, also helps you identify problems. If you have maintenance problems, if you have things that are left on, equipment that's left on, it's not always easy to see, and sometimes that'll turn up in your utility bills. Some of the simple tools for energy management. Here's my dirty laundry. This is what my house energy consumption looks like, and you can see I'm not doing so great. I'm not at that 700 level. I was in 2010, but I'm guilty of a couple luxuries, and I justify that by saying I save a lot in my daily work. So, but Excel, it's the easiest tool. Basically all I do is I take my utility bills and I enter the read date, kilowatt hours consumed in dollars, and I track that. And then I look on, year out, year in, year out, and see how I'm doing. And if you're looking at one facility or your office, this is a great way to do it. It's easy, simple, and effective. Portfolio manager. If you're managing energy consumption in a building, I think this is the tool to use. We're going to go and see if one of my hot links works again, because I don't find the Energy Star website very easy to navigate. They've got a lot of great information on this website, and they seem to really pack it in there. But to get into the Portfolio Manager tool, I'm not going to go into detail on this. This isn't a class on how to use Portfolio Manager. But to get there, you click on Buildings and Plants. And then as you scroll down, there's a quick finder, which is your Portfolio Manager login over here on the right. That's the best way that I found to get in there, and that's how I always do it. And then, so if you're starting a Portfolio Manager account, you have to create a new account. You just click the register button. We're not going to get into that any further, except I'm going to direct you down to what I find is really valuable if you want to get into Portfolio Manager, is this About Portfolio Manager section right here. They've got some great tutorials, everything you need to know about how to enter your data, and what Portfolio Manager is, how it works, what you can get out of it, and some of the advanced features of Portfolio Manager. So if you're interested in tracking your energy consumption through Portfolio Manager, this is where to start. So when you get into Portfolio Manager, the first step is to enter your facility data. They've got two ways to do this. There's a web interface, or there's an Excel template. So the web interface is designed if you have a couple buildings that you're managing, you can just enter your data through the web. If you have 10 or more, so if you're managing a campus, say like Weber State, and you have 50 to 100 buildings on your hands, you can enter your data into an Excel spreadsheet, send it up to the Department of Energy, and they'll upload your data for you. That's a really nice feature. Portfolio Manager works for 18 facility types. If you're not one of the facility types in Portfolio Manager, you're out of luck. information that you need to enter into Portfolio Manager is just your basic general facility information. Building area, operating characteristics, number of occupants, occupancy schedule, number of computers. It also asks for, which is a really good thing, if you have like a data center in your building. Data centers tend to use a lot of electricity to run, and you could really skew your Energy Star score if you don't put that in your attributes of your facility. So it gives you the opportunity to put things in like data centers or other energy hogs like a swimming pool or something like that. What do you get out of your Portfolio Manager tool? Well, you get your Energy Star score. And this comes back to the CVEX data set. Energy Star uses CVEX. And the easiest way to kind of describe what an Energy Star score is say you have an Energy Star score of 50. Basically what that means is there's 50% of the buildings in the CVEX data set, or basically in the country, are better than you for your particular building type, and there's 50% that are worse. So you're right in the middle. So if you're looking for an Energy Star label, you need a Energy Star score of 75, which means you're getting into the upper quartile of the buildings in the country. So that's pretty good. Other things that you get out of Portfolio Manager are energy intensities, both site and source. It gives you it allows you to track your energy cost, and it also allows you to track your greenhouse gas emissions. So it's a really good tool. Some of the advantages of it: it's free. That's a big advantage. Well, it's kind of free, I guess. We pay. Everybody pays taxes, I hope, and well, the taxes are going to create Portfolio Manager. So it's free with an asterisk. Data is stored at the EPA or at wherever their data center is, so you don't have any risk of data going, your server going down, you losing all of your spreadsheets that you've been tracking utility data for 5 years on. This is stored in a data center and it's secure. It's easy to apply for the Energy Star label once you get your buildings up and moving, and you're getting a couple above the 75 level. You call a professional engineer, they'll come out and do an inspection. You send in your information, and you're ready to go, and they'll send you a little, I don't know if they send plaques out anymore, I think they send stickers now, but it also does date normalization, which can be kind of a painful process if you have to do it manually. We do that a lot, but date normalization is basically you take your utility bill and you make sure it lines up for the month. Because usually the power company will come out on the 5th or the 6th or the 7th or something like that and read your meter. And then all of a sudden, you can't, so that's your January bill. You can't say, well, okay, that's my January bill because some of that consumption happened in February, because that's going to leak over, because the next read date will be in February 5th or February 6th. So date normalization says, okay, well, I'm going to take a couple days out of that December bill, I'm going to take most of the days out of that January bill, and I'm going to plunk it all into January so that I've got true consumption for January. The Portfolio Manager tool does that for you, and that's a nice feature. I was also looking into Portfolio Manager, and they also have some really nice custom reporting features. When you get into advanced management of large amounts of buildings, these are really nice. You can start cranking out pretty much any way you want to slice and dice the information in Portfolio Manager. Allows you to do that. So getting away from the tools and actually getting into some of the data a little bit and some of the actual how to manage energy. Getting utility data, as I think I've harped on a little bit, and I'm going to harp on it some more, is the hardest part. Not everybody manages their utility data very well. Here's an example of a project that we did for Salt Lake County. This is the Salt Lake County Equestrian Park. And this is a big site. That picture basically encompasses the site, and you can see all the buildings. The important thing to kind of see from this slide is look how many meters they have here. We've got 1, 2, 3, I don't know, 10, 11, 12 meters, something like that. They had no idea which meter went where. So what load, we didn't try to track it down for them. It's really hard to do. All that's buried underground. The power company didn't know. Nobody really knew. So it's a little bit of a mess. And again, I don't want to pick on Salt Lake County. This is a common occurrence. What we did is we focused on the biggest building and the biggest number. So you can see 1,153,000 and change kilowatt hours per year. That's coming from their arena. And so we focused on that. Getting the utility data is I just can't emphasize it enough. Managing your utility data will allow you to assess the energy performance of your facility. What do you do with it when you get it? Well, you take a look at it. And this is a typical way that we'll look at it. We date normalize it, so it's all in the same bin, and you're looking at it on a monthly basis. Here's some 2007 and 2008 utility data. I believe this is for a library. A couple things that you can take away from this. Basically, you draw a line on the graph, like that. And everything below that line is kind of your base load. So your base load is your lighting, it's your plug load, so it's your computers, it's copy machines, what have you, whatever, coffee machines, not coffee. And then in the summer, our load goes up, and that's air conditioning. So what this does is it gives you an idea of how much plug load, how much fixed load you have in your building, plug load, fan energy, lighting, versus cooling energy. And to me, when I look at this, just from having looked at hundreds of graphs like this, cooling energy looks pretty good. It's not a huge factor in this building, but that base load seems kind of high. And I would actually, when I would go into that facility, I'd be looking for opportunities to improve their lighting, try to work with them to improve their plug load, and probably take a good look at their fan systems, see if we can't figure out ways to save energy there. And that's what I take away from a graph like that. So there's a lot that you can take away once you've got some data to look at. You can do the same thing on the natural gas side. Here's a graph of, I think it's the same library, not 100% sure, but gas consumption, natural gas consumption, annual natural gas consumption for 2007, 2008. And the big takeaway here is what's going on in the summer. In July, you can kind of see there's a little blip. That looks good to me. That looks like domestic hot water, natural gas consumption. But August, it doubles. For a library, what do we have? A lot of people washing their hands suddenly. It's possible. But what about June? Why is that higher? Gas consumption in the summertime is an indicator of a simultaneous heating and cooling problem. And it usually hits in the shoulder seasons. And what I mean by that is simultaneous heating and cooling is an inherent inefficiency with conventional HVAC design where you're blowing 55-degree air into a space. Perhaps you don't have any load in that space, and you have to spend natural gas energy to heat that air back up so you don't turn your space into a freezer, basically. So that's an indication. When you see high gas use in the summer, you probably have a simultaneous heating and cooling problem, or maybe a maintenance issue. Metrics. Some metrics that we like to look at. UI, it's pretty common in the marketplace. That's total energy consumption per square foot per year. I like to break the UI down into electric and natural gas intensities. I think it's a kind of an eye-opening metric, and it helps you figure out where your energy efficiency opportunities are. And then, money always drives the bus. So I think that's a really good one to look at. And when you're trying to convince somebody to implement energy efficiency and invest in energy efficiency, that's a great metric to have, kind of a before and after metric. So again, UI, total energy consumed per year, divided by the building area. So what do we do with that? Okay, well here's a number of libraries that we're looking at. You can see it's the same project, 2007, 2008, we're looking at UI. And we're trying to assess energy performance. So how do we prioritize which library to go to first? Well, we plot our UIs, we go to the CBEX data set, and we go, okay, well a library is kind of like an office. I mean, libraries are, they're open maybe 9 to 6, something like that, and, it's not packed full of people, and there's, quite a few computers, and so, I would say a library is kind of like an office. And the baseline UI for an office in our region is about 80. So we say, okay, these buildings should really get down to an 80. There's our opportunities. And now you can easily prioritize of those, 10 sites or whatever we have up there. There's about 5 or 6 that really jump right out at me. You go, okay, we need to get out on these sites. They're using almost twice as much energy as they should be. Let's go figure out why. And then you don't spend time at places like the Park Library that looks like it's pretty efficient. Let's dive into this a little bit further. So if we want to look at that UI, we break it down into electricity and natural gas. One way to do that is with the electric energy intensity, and again, that's electric energy consumed per year, so kilowatt hours per year divided by the building area. So we do the same thing, and lo and behold, in the CBEX data, we can get a baseline, so we can get our yardstick for electric energy intensity. And for a building of an office building, it's roughly 15 kilowatt hours per square foot per year. And so now, this isn't as eye-opening as that first graph was, right? So everybody's not, everybody's a little bit higher, but nobody's extremely, the only ones that are kind of jumping out at me are Riverton and maybe the Whitmore Library. They're up there quite a bit, and everybody else is just a little bit high. So that means there's probably some common electric energy efficiency measures across the board that we can apply to all these facilities. So let's look at gas. Same thing. Gas, so decatherms per year divided by building area. And we're seeing a pattern again. We put in our baseline, our yardstick, and we can see that that really is going to line up with our EUI. So we've got some natural gas problems at those facilities with the high EUIs, and suddenly I know when I go out to those 5 facilities that I'm going to be looking for gas side measures. I'm going to be looking for general electric measures, but I'm going to be looking for gas side measures. And this way I'm informed before I go to the site. I know which sites to look at, and I'm not going to waste my time looking at efficient facilities. Turns out, all the facilities except for the one on the right, they were designed about the same time in the 1960s, and they used it's called a multi-zone system. It's a pretty inefficient HVAC system. We're working on getting that fixed. Another really useful piece of information is trying to figure out where your energy consumption is going. What are your end uses? Now, this isn't the easiest thing to kind of come up with. CBEX really helps again with this if you don't have any way of sub-metering or you don't have a good feel for how much lighting energy you're actually using. You can go to the CBEX data set, look at an end-use breakdown for a building similar to yours, and then you can come up with this end-use breakdown. But what this does is it allows you to, again, focus your efforts as far as energy efficiency improvements. So if you're only spending 3% on domestic hot water of your total energy in your building, you don't want to ignore domestic hot water consumption, but you don't want to focus on it. On this graph, I'd be looking at lighting and probably heating measures to try to prove the overall performance of the building. So that's how to basically do utility analysis on a set of buildings to try to inform the next steps. And so basically what's next? You can do this utility analysis yourself and then try to identify and implement the measures in-house if you have the staff or you have to know how to do that yourself. Or you can hire somebody like ETC Group, and we'll come in and we'll get a fresh set of eyes, we'll take a fresh look at your facility and an experienced set of eyes. And whether you use us or anyone, I really recommend the latter path. The experience I forget where it came from, but there's always the low-hanging fruit. Everybody wants to implement the low-hanging fruit, right? But who knows what the low-hanging fruit looks like? That's what experience in the energy efficiency industry can give you. People that know what the low-hanging fruit looks like. The other thing that I want to emphasize, don't forget about the local utility programs. Rocky Mountain Power and Questar Gas both have great demand-side management programs. That's what DSM stands for. They'll help fund some of the engineering, or they'll give you cash incentives for energy efficiency upgrades. So don't let the utilities keep them involved. So what do we do next? How do we improve the energy efficiency? Well, the next step is really assessing your facility. And there's a couple different ways you can do this. You can do this through an energy assessment or an energy audit. We've gone away from the word audit just because April 15th is coming up and everybody kind of associates auditing and taxes for whatever reason, and that's not always a good thing. So we do energy assessments. A lot of times a project just needs to be recommissioned or retrocommissioned. I'm going to spend the next 10 minutes and we're kind of blaze through some slides on this, and then we'll try to wrap it up. So energy assessments. If you're interested in this at all, or you're thinking about doing some energy assessments in your facilities, I really recommend looking at the ASHRAE procedures for commercial building energy audits. It's basically the how-to and and what to expect out of a good commercial building energy audit. And it walks you through the preliminary end use analysis, and you'll find that I just walked you through that. Basically what we just did was a preliminary end use analysis or energy use analysis for Salt Lake County libraries. Then it also defines what the different levels of energy assessments are. There's a level 1 assessment, which is essentially a walkthrough audit. A level 2 assessment, you're going to get a little bit more detail. You're going to get a end-use breakdown, list of measures, some rough economics. And then a level 3 assessment is something you want to undertake when you're looking at a big capital equipment upgrade. Say you're going to put a new chilled water plant, or you're going to replace some existing chillers. You want to make sure that if you're spending $500,000 that you're actually going to get a $50,000 return or a $100,000 return on your investment. Then I really recommend getting somebody in to do an investment grade analysis. And again, a lot of those can be funded through the local or co-funded through the local utility programs. So the first part, the first part of the assessment process is research. I've got a few funny pictures that I throw in here from all the audits that we've done. This is of a water audit. We looked at water efficiency for a lot of facilities too, and I'll talk about that real briefly. But research is key. You need to know what you're getting into. When you're on site, it's really valuable and expensive time, and you need to focus that. Drawings, doing the utility analysis that we walked through, figuring out where the energy is consumed, and identifying where the measures are, where you think the measures are before you actually get it on site. Those are critical items. Operator interviews. These guys are the best friend, are your best friends when you're trying to improve the energy efficiency of a facility. Don't ignore your operators. They know how the building runs. They know where the complaints have been coming from. They know what motors are screaming. They know everything you need to know. And so it's really important to make them your best friend when you're trying to figure out how to improve the facility. During the site visit, this is kind of what we go through. Orientation, this is what we're going to do today. These are the measures that we think we have, or the opportunities that we have in your facility. What do you think of those? Do you have any other ideas for us? That's essentially what that site visit looks like. We'll go on a tour of the facility, and we'll basically observe. We'll look at how people are using the facility. Are there a number of space heaters under desks? Well, that's a problem. And there's usually an underlying reason why people need space heaters. It's not because they have cold feet all the time. Well, it could be, but it's probably there could be an underlying issue with the HVAC system that nobody has detected, and people now need space heaters, and that's an energy efficiency issue. So after we do the site visit, you need to get all the information that you can out of your head. Basically, it's the brain dump, out of the head and onto the paper as quickly as possible, because it vanishes fast. The details vanish fast. But this is basically, we do that. We'll rough out some measure calculations. We'll put together a report, and we'll communicate that to the building owner. And this will give you a list of opportunities to improve the energy efficiency of your site or your facility. Some of the different opportunities, kind of the low-hanging fruit, lighting. Lighting's a really big chunk that, it seems that every 7 to 10 years, the lighting efficiency takes a step. So in the 90s, it was compact fluorescents. In the, I don't know what we are, but in the zeros, it was LEDs. But these are some of the typical lighting retrofits that really make a lot of sense. So if you have any of this lighting technology in your facility, think about upgrading. Metal halides, T5HO retrofits, that upper picture on your right, that's what that was. That was a metal halide retrofit. We put in some T5HOs there. Fluorescent upgrades, T12 to T8. T12 lamps are no longer going to be manufactured, so get those out of your facility, because pretty soon you're not going to be able to replace your lamps. Standard to premium fluorescents and occupancy sensors or lighting controls. The bottom picture is an interesting picture of a horse barn. You can see kind of down the middle, there's a row of fluorescent lights on, and this is in the middle of the day, and they've got a great daylighting design in there, right? So you couldn't tell the difference if you had those lights on or off, because there's so much natural light coming into the space. And then I would guess the horse would probably prefer natural light over fluorescent light, but Water efficiency, I mentioned we looked at this, and I just want to bring this up because this is a sustainability conference, and water is going to play a huge role in a sustainable future. And there's a few no-brainers that everybody should look into. Aerators, low-flow aerators, do this at home if you can. 0.5 GPM aerators, you can buy them for $2 at Home Depot and they screw right onto your faucet. Low-flow shower heads. I've got one in my basement, and I actually took a shower with it this morning, and it was fine. It was, around, I think, 1.2 GPM instead of 2.5, 2.25. And you can buy them for $20. And dual flush retrofit, that's what that is on the right. Now, not everybody has these in your house. I'm guessing nobody has them in their house. But you see them all over in commercial facilities. And this is just a way to basically up, you get a third of the water, and down you get a full flush. And it's a nice, if you own or manage facilities, I really like the marketing aspect of this because they sell these uppercut retrofits. You can retrofit your plumbing, and you have a little green handle, and then you have a little sign, and it'll tell you what the green handle is all about. And so it's a nice little marketing bit. And it's a fairly cost-effective retrofit. It's about $150 to retrofit that kit. So that's it on energy audits and energy assessments. Next thing I want to talk a little bit are some of our experience with retrocommissioning and recommissioning. Right, what's the difference? Retrocommissioning or recommissioning? Recommissioning is commissioning an existing building for the second time. So a building's been commissioned, and the recommissioning process goes in after 5 years or so and gets it back to working condition or new condition. This is something that should be done on most commercial facilities. Buildings are kind of like cars. You know how you've had your car, and say you had a new car, and it's pretty nice. 5 years later, you start hitting that maintenance wall where you have to start spending a lot of money on your car to keep it working right. Buildings aren't any different. They degrade over time. And if you don't go back and get it working like it should be, you lose a lot of low-cost energy efficiency opportunities. Retrocommissioning, on the other hand, is when a building was never commissioned. So these are the buildings that you go out, and I was talking to Jake earlier, and you go out and you find plastic wrap that was never removed off of direct evaporative cooling section, and it operated like that for 6 years and nobody caught it. Buildings need to be commissioned. If they haven't been commissioned, they need to be retrocommissioned. Get them right, get them working right from the get-go. The retrocommissioning process involves a planning phase, an investigation phase, implementation phase, and a verification phase. Planning phase is basically saying, this is what we're going to do, this is what we're going to test, this is what we're going to look at. Investigation phase is executing that plan. So you go out and you do your tests, you test your air handlers, you test your pumps, you test your chillers, you test your hot water systems. And when you're done with the tests, you have a list. You kind of have a laundry list of retrocommissioning measures to implement. Implementation is exactly that. You implement. So you fix everything, and then during verification, your retrocommissioning provider will come back out and make sure everything was fixed correctly and you're getting your savings as expected. That is kind of an arduous process. Planning, investigation, implementation, verification. We're finding that a better approach is kind of a find and fix approach. Where a retrocommissioning provider goes out in the field, you partner up with a contractor, whether it be a controls contractor, mechanical contractor, electrical contractor. You find the problem as you go through, so you basically combine the planning and investigation phase, and you do that all at once, and you go through a building, and then the contractor follows you along and fixes the problems as you find them. Why this is important is because typical retrocommissioning projects have a really quick payback. And if you take 6 months to implement retrocommissioning measures, you could have done it in a month, you're losing that revenue source because the retrocommissioning measure would have paid for itself by the time you were done with implementation. Does that make sense? Other benefits, typical retrocommissioning projects are O&M issues. It's deferred maintenance. A lot of times maintenance is driven by who screams loudest. And the maintenance people are running to put out those fires, and they don't have time to fix the energy performance of the building, or maybe they don't have the training to know how to do that. So coming in and doing a retrocommissioning or a recommissioning process often helps to identify those measures and those issues. And a lot of times there's control problems out there too. A couple examples. Here's a great example of a pump control override. And this is also an example of knowing what the low-hanging fruit looks like. So it's a variable speed pumping system. And the before picture, kind of hard to read, but on the left is speed. And this pump is running flat out at 50 hertz. And basically what happened on this, on a VFD, there's a little button that says hand or auto. And this pump VFD was put in the hand. And it was fixed at 50%. So that meant it was constant 50%. It was designed to be a variable speed pumping system. It was designed to modulate the pump speed to meet the building load. All you have to do is switch the thing into auto, and it'll actually start to modulate the pump speed. And so that was the measure. We flipped the switch, and we went from 50 hertz down to, I think that's about 30 hertz. And you can see it modulating based on load in the building. No cost measure. And I don't exactly know what the size of the pump is, but we're talking about a 50% reduction in speed. So we're talking about somewhere around a 75% energy savings, just for flipping a switch. That's what I mean by identifying knowing how to identify the low-hanging fruit. Not everybody knows how to identify it. Here's a good one that I think everybody can relate to. I relate it to a programmable thermostat in your house, because everybody knows what that is, and they're not the easiest things to use. But it's basically turning your temperature set points in your house down at night or when you're not around, so that you save. You turn your furnace off, basically. Commercial buildings are notoriously bad for not doing that. And here's an easy one. You go in and you schedule your VAV, your air handling system, to match the building occupancy. In this particular case, this is a hospital right across the street from Weber State. And hospitals are almost always 24/7 operating facilities. Well, they had a little chunk of space in this building that was basically office space. Nobody was there at night, but they had it scheduled 24/7. So all you have to do is go in and schedule that space to match the occupancy. Schedule that HVAC system to match the occupancy. And you're going to get a bunch of savings. You're going to turn that air handler off, you're going to get cooling savings, and you're going to save reheat, because you're going to have to reheat all that cold air that you're blowing into the space back up because nobody's in there. They're kind of common sense measures, and there's a lot of them out there. So here's a graph of what happened. So there's the before. Just pay attention to the big red line. So we're at 60% speed in this case. So that's before scheduling. You can kind of see it's modulating 60, maybe up to 70 a little bit. And then we schedule it. And it drops down from 60 to 40% speed. And then you can see it modulating up to 60% speed during occupied hours. Savings from 60 to 40%. It's not as significant as the pump measure, but we're still saving some energy. And there's lots of opportunities like this, just about in every building that you go into. I think this is the last example I have, but it's a good one. Building pressurization problems. It's common. It's a hard building control issue. Buildings are complicated beasts. This is a project they had pressurization issues, and a great indication of a pressurization issue is leaves in the lobby. If you've got a bunch of leaves blowing in your lobby, you've got a pressurization issue, because then your building is negative. So you're sucking in leaves from outside, and when you open the doors, the leaves are getting sucked in. Well, that's not the only place where cold air is getting sucked in. It's in every little crack in your building envelope, air is getting sucked into the building, and then all of a sudden, you've got somebody with cold feet. Well, their cold feet are because there's a crack in the building envelope. And you have a negatively pressurized building, and it's pulling that 20-degree air from outside in, and it's hitting that person's feet. And so what do? They put in a space heater. And suddenly you have all this electric resistance heating throughout your building, and your energy use goes through the roof. So how do you fix that? Well, I'm not saying building pressurization, fixing your building pressurization is the magic bullet, but it can help. And this is the before and after. we went in and redid the control sequences to try to get the building a little positively pressurized and reduce that infiltration. And you can see the impact that we had there. And when you're below the red line, you're sucking in air. When you're above the red line, you're positively pressurized, and you're using your much more efficient HVAC system to condition your air. So benefits of the retro-commissioning process: energy savings. There's lots of ways that you can get energy savings. These are just a few, but you're going to get energy savings out of the retro-commissioning process. And you're going to also increase your equipment service life. A lot of times you'll go in and you'll see valves that'll be isolated or oscillating back and forth, opening, closing, opening, closing. Sometimes they'll be doing that every minute. They'll wear out in half the time that they should. So retro-commissioning will also decrease your maintenance costs, increase your equipment life. So, in conclusion, I've been talking way up here for quite a while, but if you want 4 points to take away, manage your energy consumption. It's critical. It's critical if you want to improve the energy efficiency of your house, your workplace, or the buildings that you manage. Once you've got that, your arms wrapped around that, go out and assess your facilities. Either do it internally or hire an energy efficiency expert to help you out. Invest in energy efficiency. Don't be afraid to invest in energy efficiency. I think it's one of the best investments that out there, and I think we're going to see that moving forward as energy prices go up. The investment in energy efficiency is only going to get better. It's kind of interesting in Utah. We have some of the lowest energy costs in the country. You go out and you start looking at the Californias and the New Yorks, where they are paying around 20 cents a kilowatt hour compared to our 6 cents a kilowatt hour. And a lot of these energy efficiency project economics start looking great. And last, don't be afraid to leverage the local utility programs. There's great programs out there. They'll pay you to upgrade your lighting, your HVAC systems, and they'll also pay, some of their incentives are energy consulting, energy engineering. And so they'll help you get that assessment process done. With that, thanks for your attention. I hope you got a little bit of information out of Energy Efficiency 101, and I'm happy to hang around or field any questions.